Hello, geometers. This is Miss Backfish, and I am here to resume talking about area and perimeter of polygons in the coordinate plane. This is just a reminder. This is video 2. In video 1, we talked about perimeter, area, distance formula, and particular area formulas for various shapes. We also did these two problems, and now we're ready to finish off 3, 4, and 5. And we're going to jump right in with number 3. Now, it looks to me like that's a trapezoid, all right? But I can't just go on looks alone. So I'm going to go ahead and I'm going to confirm that this is a trapezoid. Let's label the side, or label the vertices. I'm going to call it A, B, C, D. So it looks to me like AD and BC are parallel. Now, honestly, when it's like this, where they're actually vertical lines, they're on grid lines, you are probably safe to go ahead and just say, and I say probably, it depends on your teacher. It depends on what your teacher wants of you. But I would be fine with you saying, well, these are vertical lines, so I can tell that they're parallel. All vertical lines are parallel to each other. All horizontal lines are parallel to each other. So I know that I have one pair of parallel sides, and that's what gives me a trapezoid. But let's suppose that they weren't vertical lines. Then I would need to find out by confirming. I would need to say, I think these two opposite sides look to be parallel. I need to find their slopes to double check. Let's go ahead and get our coordinates. A is at -3, 3. Always be very careful finding your coordinates, because if you mess up the coordinates, it's going to throw off everything. C, watch me do it. No. 1, -4, and D is at -3, -2. Okay. So the slope of AD, change in y on top, change in x on the bottom. Rise over run. The difference between the y's over the difference between the x's. And it doesn't matter which point you consider 1 or 2, as long as you go in the same order. So I'm going to say point A minus point D. So 3 minus a -2 on top. And the x is -3 minus a -3 on the bottom. So this gives me 5 on top, and on the bottom, 0. Okay? Fractions that have a 0 in the denominator are undefined. So what does that mean? Well, it really means that I just confirmed that it's a vertical segment. Okay? It has an undefined slope. Let's look at BC. Change in the y on top, 4 minus a -4. Change in the x on the bottom, 1 minus 1. Again, I'm going to have a 0 in the denominator. It really doesn't even matter what you have on top. If you have a 0 in the denominator, it is undefined or no slope, which means I have a vertical line, or vertical segment in this case. So yes, these are parallel. AD is parallel to BC. So I do have a trapezoid, and so I'm going to use the trapezoid area formula. Now, the parallel sides of a trapezoid are the ones that are the bases. So in this case, my bases are AD and BC. It's awfully handy that they are vertical, because when you have vertical segments, if you want their lengths, you can just count. The length of AD, 1, 2, 3, 4, 5. Remember to count the spaces, not the grid lines or the marks or anything like that. The length of BC, 1, 2, 3, 4, 5, 6, 7, 8. So that's like my B sub 1 and my B sub 2 in the trapezoid area formula that looks like this. And again, it doesn't really matter which one's base 1 or base 2. Now the next thing I need is the height of my trapezoid. The height of a trapezoid is the distance between the bases. So since those are both vertical lines, the segment that goes between them and shows the distance between them is going to be a horizontal line. So thankfully, once again, I can just count. I'm going to call this my height. It's perpendicular to both the bases, which it has to be the height. And I'm going to count 1, 2, 3, 4. So the height is 4. So my area is 1/2. Add together the two bases and multiply times 4. That should give me 26 square units. So there's my area. Now the next thing I need is the perimeter. Perimeter is distance all the way around. Let's go ahead and say A for area. Well, I already know the length of AD and the length of BC. So I'm going to use those when I start thinking about perimeter. AD is 5, BC is 8. I need to know this distance and this distance so that I can add up all my sides. So to find the length of AB, I'm going to come over here. Let's see how can I rearrange things. I want to make sure I can see this. So let's scoot this over. And the length of AB, using these coordinates, distance formula. Remember, this is the distance formula. It's the difference between the x's, which is like saying the horizontal distance, and the distance between the y's, which is like saying the vertical distance. In other words, how much do you go left and right, and how much do you go up and down. So the distance between the x's is between -3 and 1. The distance between the y's is between 3 and 4. The order of subtraction doesn't matter because you're going to square it anyway, and the only difference would be the sign before squaring, and that goes away basically. If you square a negative or square a positive, if it's the same number, it doesn't matter, you get the same thing. So keep in mind, this is what I'm talking about. The distance between the x's, that's the same thing as if I had counted the horizontal distance here. 1, 2, 3, 4. I'm going to get -4, but it's the same idea. 1. These are just one apart from each other. So this gives me -4 squared, which is the same as 4 squared, -1 squared, which is the same as 1 squared. 4 squared plus 1 squared gives me square root of 17. That does not simplify. Now the other one I need is DC. So let's go ahead and find DC. Distance between the x's is 1 minus -3. Distance between the y's is -4 minus a -2. This gives me 4 squared, which is 16. This gives me -4 plus 2 is -2 squared, which is 4. So that's square root of 20, which simplifies as 2 root 5. So for my perimeter, I'm adding up all the sides. 5 plus AB. So 5 is, let's go ahead and just move this back over. You know that AD, this side is 5. I'm going to just trace the distance around as I do it. Perimeter is adding up all the distances, all the side lengths. So 5 plus AB is square root of 17 plus BC is 8 plus DC is 2 root 5. Okay, the 5 and the 8 are like terms. Anytime we're adding or subtracting, we're combining like terms. 5 plus 8 I can put together and get 13. The only way radicals are like terms is if they have the exact same number underneath the radical. These are not like terms, so if I'm leaving it in exact form, I can't combine them and I'm done. Now, if I'm asked for a decimal approximation, then sure, I can see what the calculator has to say about that. But if you're asked to put your answers in exact form, that would be the final answer. Decimal form, looks like we've got about 21.6, let's just go with 21.6. 0.60. And that's my perimeter. All right, next up, we have what looks to be a parallelogram. I'm going to go ahead and just go with the fact that I can see that this is horizontal. I can see that this is horizontal. Again, oh, excuse my cat walking through the frame. Trying to stick around for a little while. It's up to your teacher. If your teacher tells you, I still want to see you finding the slopes of these, then find the slopes of them. All right? But if you find the slopes, because they're horizontal lines, you're going to get 0 for both slopes. Let's go ahead and give this some M, N, P, R. Okay? So M, N, I cannot keep the cat from jumping up on the desk, sorry. MN and PR have the same slope. They are both a slope of 0. They are both horizontal, so they are parallel to each other. Okay, so I know that much. Let's see about the slopes of RM and the slope of PN. Okay, I'm going to do it visually. I'm going to say, let's go from R to M and see what I have to do to get from R to M. I have to go up 1, 2, 3. Up is positive, and up and down goes on top. That's the Y. Then I have to go right 1, 2. Right is positive, and right and left go on the bottom, so positive 2, that's the change in X on the bottom. So there's my slope. I can't simplify that. Let's come over here. From P to N is up 1, 2, 3. Then 2 to the right. So up 3 on top, change in Y goes on top, up and down, right 2 on the bottom. The change in X, left and right, goes on the bottom. I have the same slope. So I know that RM is parallel to PN, and so I do have a parallelogram. Let me just point out, if you had done it in a different manner, I just messed up my pen, I think. If you had started here and said, I want to know, I'm going to start here and I'm going to go left first and then down. Okay, left 2, that's negative 2. That would be in the denominator because left and right is in the denominator. Down 3, 1, 2, 3. That would be in the numerator. But look what happens. A negative divided by a negative is a positive. So you still get the same thing, even if you do it in a different order than I do. All right, formula for the area of a parallelogram is just the length of the base times the length of the height, basically. It's 2 lengths, base times height. All right, I'm going to say that RP is going to be my base here. And since it's horizontal, I'm just going to count. Actually, let's count first, but let's also use the distance formula. I want to show you what happens if you do that. 1, 2, 3, 4, 5. Looks to me like RP has a length of 5. And I did mess up my pen here. And I'm going to have to do something about yon cat here. Okay, let's say I had not felt like I could count, and I needed to figure out, using distance formula, how long RP was. So this is, R is at negative 4, 1. And I really did mess up my felt tip here. Sorry about that. And P is at 1, 1. And I'm going to use the distance formula. So the distance between those two, negative 4 minus 1 squared plus 1 minus 1 squared. Well, look what's happening here. 1 minus 1 is just 0. Okay, 1 minus 1 is just 0. So this doesn't make a difference. In other words, this would give me negative 5 squared plus 0 squared. Well, that's just the same as negative 5 squared plus nothing. So that's this. All right. If we square negative 5, we get 25. Take the square root of that and you got 5. So even by doing the distance formula, we would still get 5 for RP. Now, base times height, the height in a parallelogram, just like in a trapezoid, it has to be perpendicular to the base. It doesn't have to, well, it has to be perpendicular to both bases, really. Or both sides, the base and the side across from it. All right, so I'm going to let this be my height. And since it's vertical, I could just count. 1, 2, 3. So the area of my parallelogram here is 5 times 3, which is 15. Okay, perimeter. Well, I can count for RP. I can count for MN. So let's go ahead and say RP is 5, MN is 5. I need to find RM, and I need to find PN. It's a parallelogram, so actually I don't need to find those. Yeah, I do. I'm sorry. I lied. Going back and forth here. It's a parallelogram, so I know that opposite sides have the same length. So all I need to do is find one of them, really. Okay, so let's go with RM. RM is, let's see, we need to write our coordinates down here. R is at -4, 1, and M is at -2, 4. So the difference between the x's, -4 minus a -2 squared, plus the difference between the y's, 1 minus 4 squared. This gives me -4 plus 2 is -2. 1 minus 4 is -3. So we basically have 2 squared plus 3 squared, and that's square root of 13. Sorry, you couldn't see it. And that's going to be the exact same as its opposite side, which is Pn. So for the perimeter, I have the 5 here, plus that root 13 over here, plus the 5 here, plus the root 13 over here. Okay, let's actually just go ahead and draw that out. I feel like we're getting a little bit visually cluttered. This is the scenario we have here, based on what we have found. Okay, so I can just say 5 plus 5 plus root 13 plus root 13. Adding up all the sides, that's 10 plus 2 times the square root of 13. That's the exact form answer for the perimeter. And if I want decimal equivalent or decimal approximation or decimal equivalent, I type that in and get 17.21 about. And that's my perimeter. All right, last but not least, we have a triangle here. And what I wanted to show you this triangle for is I wanted to point out, and let me draw it again over here, because I want to point out what can happen. Let's see. All right, this is basically the same. Sorry, I'm not using a straight edge here. Yeah, that actually went right through here, didn't it? Sorry. There we go. Okay. Remember that area of a triangle is 1/2 base times height. Your base can be anything, but the height has to be perpendicular to the base. It has to be an altitude. So let's say, for instance, I could pick this as the base. I could find this distance as the base. I don't have any vertical or horizontal lines here. So there's not one that's screaming, pick me. Okay? Then my height would be somewhere like this. It would not be on that line because it has to be perpendicular to this, which is not horizontal, so it can't be vertical. So this could get complicated because I would have to figure out where it touches this line. So that would involve finding equations of lines. I would have to find an equation for this line. Then I would have to find an equation for a perpendicular line, a line perpendicular to it, that goes through this point. And then I would have to see where they intersect to find this point. And then I would have to use distance formula to find the distance between them. So that could get kind of messy. So check and see if there's something easier going on. Always check to see what is the easiest way to do this. If two of my sides are perpendicular to each other, then I can use them as the base and height. In other words, what if this is my base? Could it just so happen that this side is perpendicular? Could this be a right angle? Well, let's check. Let me give it some letters. J. Oh, my felt tip does not work at an angle any longer. What I did, in case you're wondering, was I had the lid for a marker in my hand and I tried to jam this in there instead of in its and I smushed the tip. Okay, so LK has a slope. Remember, perpendicular means opposite reciprocal slopes. So slope of LK. Well, let's find the coordinates here first. The coordinates of J are -4, 1. Coordinates of L are -2, -2. And the coordinates for K are 4, 2. Okay, so the slope of LK is subtract the y's, so I'm going to do 2 minus -2. That minus this. So if I started with K on the top, I need to start with K on the bottom. So 4 minus -2. That's the only thing that matters about slope, is that if you're, about order of subtraction with slope, is as long as you do it in the same order, you're good. 2 minus -2 is 4. 4 minus -2 is 6. That's 2/3. Okay? Now let's look at the slope of JL to see if those are perpendicular so that I can use them as base and height. Okay? Do the y's on top. Rise on top. So 1 minus -2 on top. 1 minus -2. Started with J this time when I did 1, so I need to start with J for the x's as well. -4 minus -2. All right, 1 minus -2 is 3. -4 minus a -2 is -4 plus 2, which is -2. Are these numbers opposite reciprocals? Yes, they are. Another way of saying that, by the way, opposite reciprocals means opposite signs. One's positive, one's negative. Reciprocals means flipped over. Okay, another way of noticing that lines are parallel is to say that their slopes, when multiplied, should give you -1. And they do. That's a way of checking that we have opposite reciprocal slopes. So now that I know that LK and JL are perpendicular, I can use those for my base and height in my area formula. Here's the area formula of a triangle. And that means I'm going to do 1/2 the length of LK times the length of JL. So I better find those. Okay, LK times JL. So let's go ahead and find that. Length of LK. I need to get my coordinates up there again where I can see them. Let me go ahead and move this up here. Length of LK. Distance formula for LK is the difference between the x's squared plus the difference between the y's squared. That's, let's see, 6 squared. 6 squared is 36. That's what this is right here. And this is 4. 4 squared is 16. 36 plus 16 is 52. Do any perfect squares go into that? Yes, 4 does. So that should be 2√13. Now what about JL? JL, the difference between the x's, 4 minus a -4 minus a -2, plus difference between the y's, 1 minus a -2, gives me, excuse me, 2. That's -2 squared. This is a -2, everything in the parentheses there. When I square that, I get 4. 1 minus a -2 is 1 plus 2, which is 3. When I square that, I get 9. So this is square root of 13. All right, so when I'm doing the area formula, 1/2 LK, which is 2√13, times JL, which is just √13. 1/2 times 2, those are going to cancel. 1/2 times 2 over 1 is just 1. And then √13 times √13 is just 13. So there's my area. Now we have the area. All we have left to find is the perimeter. But fortunately, we've already found the two sides I've traced there. We've already found LK length. That's 2√13. And we've already found the length of JL, which is square root of 13. All we need left is the length of JK. So let's look at our coordinates again. JK, difference between the x's from -4 minus 4 squared, and difference between the y's is 1 minus 2 squared. So that gives me Negative 4 minus 4 is negative 8. Negative 8 squared is like 64. Or it's not like 64, it is 64. Negative 8 squared is like 8 squared is what I was trying to say. 1 minus 2 is negative 1. Negative 1 squared is 1. So I get square root of 65 here. So my perimeter in exact form is 2 root 13 plus root 13 plus root 65, which these two can be combined, so I'm going to call that 3 root 13. This is like if I have 2 of something and I add 1 more of it, 2x plus x. There's the exact form answer. Let's go ahead and change that to a decimal. Or let's turn on the calculator before we try to do that. That's always helpful. And we get 18.88. I hope this has helped, and you see that these are very doable, and yes, they're a little bit tedious because you just have to do quite a few calculations about one figure to show everything you need to show. But once you've done a few of them, you can start to pick up steam on them, and you start to feel more confident and get them done pretty quickly. So I hope it's helped, and I'll see you next time.